So we have seen the different type of logic operation we can apply in C language. Now we have to go for what we call bitwise operations. Now you see, always remember one thing, that bitwise operation means it is a logic operation but bit by bit. That means, what I mean to say, that if I go for a bitwise operation, mean logic operation bit by bit. Okay, logic operation bit by bit. So that means, what I mean to say is that in previous case we have seen that if we have a situation a equal to 5, b equal to 10, and then if we apply like this, I have told you that you have to don't need to go for this value 5 and 10, rather you have to see whether they are 0 or non-zero as a whole. But this is not true for a bitwise operation. That means if I write the same thing, a equal to 5 and b equal to 10, and then if I, how we can write the bitwise AND operator, I can say that a and b, that's all. What will be the output? You see, when compiler will see that we have a only one AND, that means it will understand it is a bitwise AND operation, logic AND, but on bit by bit. What does it mean, bit by bit? Bit by bit means that just think a not as 5, just as a binary string. If we consider binary string of 5, it will be 1 0 1, or in 4 1 0 1, this is 5, right? And what is the binary of 10? That is 1 0 1 0. So to make them same length, I will keep this 0 over here, right? So this is 10. Now this, due to this AND operation, what will happen? We will have AND, logical AND operation on bit by bit in this particular, between these two numbers 5 and 10. So in previous case we did it as a whole, but now we will not do it as a whole, we will do it bit by bit. That means 1 will be ANDed with 0, only these two, and result of these two will be stored here. Then this one will be ANDed with the second one, result will get stored here. By chance, in this situation we have seen that basically 5 and 10 are complementary, right? I mean, wherever 1 is present in 5, the corresponding position for 10 is 0, and vice versa. So that's why you will see that every time it will be 0, right? And this 0 in binary will be now converted to decimal, and we know that binary will be 0 in decimal also, and that will be the output of C. So if you print C here, you will print, basically you will get output 0. That is the difference between a bitwise logic operation and a simple logical operation. So that means, in case of a bitwise operation, there is no guarantee that if we have two non-zero value, the output will be non-zero always. Output can be 0, can be non-zero, can be anything. It totally depends upon the bit by bit logic operations output. And this one is true for the other bitwise operations. For example, if I do the same logic, I mean if I have a same logic, like if I write D equal to A or B, so A or B means this A remain 5, B remain 10. So here 5 means we have seen 0 1 0 1, and 10 means 1 0 1 0. And if I do bitwise OR, that means bit by bit OR operation will be continued. So by, since it is, you can see that 5 and 10 are basically complementary for the 1 0 combinations. That means, you see, in case of OR operation, we know that if one of the inputs are out, true, then output will be true, right? So that means in one of them is true, then output will be true. That means output will be 1 for this case, similarly 1 for this case, 1 for this case, and 1 for this case. And you see, this is the binary combination. And if you find the corresponding decimal, it will be basically 15 in decimal. So that means if you print D, you will get output 15. So this is the difference between a bitwise operation and a bitwise logic operations and simple logic operations. Now in the bitwise operator, two very important operators are left to discuss, that is this shift operation. So let's discuss it first. What is shift operation? For example, if I say that, suppose A is given as say 13. Okay, A is 13. And if I so what is the value of 13? You know, in binary it is 8, 12, 13. If I express it in 8 digit, it will be something like this, right? 0 0 0 0 1 1 0 1. Now a bitwise operation, let's see how a bitwise operation work. If I write B equal to A 2 less than 2, I mean this is what we call bitwise left shift. Okay, bitwise left shift. How many times left shift? 2 times. Instead of 2 times, if you write 3, that means you will have a bitwise left shift 3 times. Now what does 2 times and 3 times mean? Let's try to realize it. That means if we write that 0 0 1 something like this, what will happen? Just assume that, and assume a scenario something like this. Let's draw it here. Okay, a tape. So this is your memory where the data are given. Okay, 0 0 0 0 1 0 1 0 1 1 0 1. So this is 13. Now bitwise shift means, assume that this, all this position of these zeros and ones will be shifted towards left. How many times? 2 times. 2 times means that whatever 1 is present in this position will come here in this part. That means this particular 0 will come out from this position. even this will come out from this position, because if you go for left shift 2 times of this two part, it will come out from this two memory, two tape. What will happen? This 0 will be shifted over here in the two left positions. Similarly, if this 0 will come here, right? So that means what will happen? This 1 will come now in this place, right? Then this 1 will come in this place. Then this 0 will come in this place, and this 1 will come in this place. Now, who will fill up these two places? This will be filled up by 0. So that means after shifting 2 times, the new data, new binary combination that we have got is something like 0 0 1 1 0 1 0 0. Now if you just want to find the corresponding decimal, it is 0 1 2 3 4 5 6 7. So this is what 1 into 2 to the power 5 means 32 plus 16, that means 48. 48 plus 4 means 52. So that means this is equal to 52 in decimal. So that means if you print this variable b, it will produce output 52. Now see, this bitwise operator has a very important activity. Not only this left shift, if I can have the same thing for a right shift also. For example, if I just do one thing, just I write say C equal to A 1, it means that we will have a bitwise right shift. This means bitwise right shift. How many times? 1 times. So that means what we had, the original number was 0 0 0 0 1 1 0 1, and if it is right shifted by 1, that means this one will throw out, and instead of 1 this 0 will come, this 0 will come, then 1 will come, then this second one will come, and the other 4 zeros will come one by one. Sorry. And this position will be filled up by a 0. So as a whole, this become the new result, that is this is what, this is 6. Right. So if you print C, it will be print 6. So this is the basic idea of the shift operation, that is left shift or right shift. Now how many times you are shifting depends on that, the number will change. Now what this shift operation has an importance, let's see an interesting visualization. That is, suppose we have a equal to 6. Okay, a equal to 6, and if I write b equal to a less than 1, it means we are shifting this a once and storing in b. So what is the status of a? Let's see first. The status of a, if I just express it in 4 length binary string, it will be 0 1 1 0. If you cannot understand these changes, you can check it by in your home, you can check it, the just convert this 6 to binary, you will find 110. I have just added this 0 to make leg 4, because left added 0 in the left side doesn't make the make any change in the original number. Now what I have done B leftwise shift once. Since I want to shift leftwise 1, that's why I have given the 0 to understand it better. So anyway, so what will happen? This 1 will come, I mean as a result of this shift operation, what I will get? This 1 will come here, this 1 will come here, this 0 will come here, and the 0 that is left will be filled up by 0, right? So now you see, if you check the value that it possesses is actually, if you find the corresponding decimal value of this number, you will find it is 12 in decimal. So you see, in A I had 6, and if you print B, I will get 12. So what happened? The number has doubled. So that means if you want to, if you have some number stored in a particular variable and somehow depends on your logic, you want to make it double, you don't need any extra logic to do. You don't need to multiply it by 2. You can just left shift it by once and you can do this. There is another scenario we can have. That is, if we have a situation something like, for example, as I can say that suppose A is equal to 15. Okay, I have written A equal to 15, and here I have written B equal to A double greater than 1. What does it mean? Means bitwise right shift once time. So I had 15 means 1 1 1 1, right? And if you right shift once, so basically what will happen? This one will come here and this one will be thrown out. This one will come here, this one will come here, and this place will be filled up by 0. So as a whole, if you look this binary number, if you want to convert this, you will get it is 7 in decimal. So basically what happened? If you print this B, you will get output 7. So that mean I can divide the number, instead of dividing the number by 2, if I do just simple right shift once, I can get the number, I mean actually the half of the number. Actually you can say the quotient of the number. For example, if you divide say B, if you write B equal to A by 2, the value that you will get is same that you will get in this way. Right. So that means whenever a computer tries to find the double of a number through hardware, it does not go through for some multiplication operation. Rather, it's go for a simple shift operation once, either left shift or right shift, depends upon whether it want to double or want to get the half of the number, and it can easily find the result. From the hardware perspective I am saying, okay, not from your perspective, I am saying from the perspective within a machine. So we have a separate shifting unit in a computer that is used for shifting a number some in amount of times, either left shift or right shift. So As we will grow up, we will see the more detail of the computer system, the hardware part. There maybe you will able to understand that how these shift operations happen through the hardware, because there are many other concepts will come. There is a specific memory location we have, that is what we call shift register. Okay, that shift register is responsible for these shift operations. So, I mean, in the next semester, maybe you will have a subject digital electronics or digital logic design. There you will see the, there you will be actually it will be introduced to you various hardwares and the total idea of a very basic in components we have within a computer that are responsible for different logic operations present in a computer.